don't know if this is.
You have to choose and for the discussion part.
Okay. Okay, so as Jessica mentioned, I had a life before joining EPFL and in particular the Enterprise for Society Center. Now I just lead the operations of the center, so helping the directors implement their projects and so on. So it's very operational. I'm no longer doing core research myself. So this dates back from my postdoc at the University of Geneva, right before I joined IFRS in 2020. This study was done back then. Before Geneva, I did a PhD in economics at the University of Lausanne, preceded by a master in Lausanne, and way before a license in economics at the University of Buenos Aires, Argentina, where I come from. So economist 100%, let's say. So this study actually was born, we were not precursors or foreseeing an epidemic per se. Actually, it was born out of two facts. The very first one is like, we started to see all these digital tools coming up and being used widely, but we didn't find a lot of evidence about, how effective these tools were for, helping students learn or anything that you may care about, students' welfare or, attendance or classroom overcrowding. This second point was the one that actually led us to do this study. It was at the University of Geneva. Bachelor courses, like pretty much everywhere in Switzerland, were like totally overcrowded. So students sitting outside the room, complaining, cohorts going up every year. So this was a problem. So the university wanted to simply, start live streaming everything pretty much. So this is when we jumped in and we say, well, let's take this opportunity to test and learn a little bit of how effective these are, because otherwise we're going to, invest a lot in displaying this technology. And if it doesn't help, it's kind of lost money. So it was really not at all about COVID, but definitely COVID helped us get it published because it just hit right after the study. So in a sense, the learnings could be generalized a little bit in the post-pandemic context. So what we did is testing live streaming. It's a very particular learning tool. You could say it's not online learning, in which there is nothing that differs substantially between a course that is in person or live stream, because students can see not only the filming of the lecturer, they can also zoom the screen, the screen sharing that the professor does, and they can see a little bit people in the classroom, like if they were inside, sitting pretty much in the middle of the classroom. So it's very, very similar to the in-person, but you don't have kind of the background noise or the interaction with the other people inside. These lectures were not recorded. It was really live streamed. So people could connect 5 minutes before, 5 minutes after, no recording possible. So either they connect or either they lose the course, let's say. So what we did is kind of give random access to the students. Some students could always access this streaming platform. Some students never. Some students, some weeks yes, some weeks no. I'll explain a little bit more how we did that. Crucially, what we find is that, first of all, the students take up this service very rarely. So even if they have access, most of the time they don't use it. It's about 10%, the amount of time that they do use it. And the second result is that exam performance goes up for students of high ability. I'll tell you how we measure ability and we can debate about that. But it goes down for students of lower ability. So on average, we do not find an effect. On average, this technology is kind of neutral in terms of exam grades. But if we kind of dig into, students' background, we learn that some are benefiting from the technology and some are not. In terms of grades, of course, benefiting, they may benefit in other, comfort of being home and etc., but not in terms of performance in the exam. So the experimental setup. What we did is, first of all, focus on first-year bachelor students, mandatory courses. So, they were all pretty much the entire cohort should be taking these courses. Well, into 2027, so we had 2 waves in the spring and in the fall. There was no, of course, like here at the PFL, there's no enforcement of class attendance or not. You cannot tell a student you're forced to come to class or not. You do whatever you want in the end. Same thing is like we cannot force them to connect and not come to class. So we divided randomly a sample of 1,600 students into 3 groups. Like 50% of these students, they never had access during the entire term. Meaning, so those are 13 weeks of the term, they could never connect. And crucially, this access is like via some sort of Gaspar account. So it's individual. So if you want to share your login with somebody that does not have access, it means that you share your Gaspar ID login. So that's pretty problematic. So it's not really likely that students will be kind of sharing access with those that do not have. Some people always had access, so they could actually stream the entire term, pretty much. And some of them, they had sometimes access, meaning that we just randomly gave them a list. This week you have access, next week you don't. The week after you don't, afterwards you do, so it's a bit random. The nice thing about this is that we are able to kind of multiply the number of observations. So if we only looked at 1,600 students, you know that statistically you can do as much with that sample. But if all of a sudden each student multiplied by 13 the numbers of observations, meaning that each week something different is happening for these people, you enlarge your sample, which allows you to do better, more powerful inference afterwards. Then you may tell me, well, but in the exam, how do you map the exam with the weeks in the end? You have one grade in your exam. And this is why, you know, the professor's kind of buy-in was crucial. What we did is like each exam, it was multiple questions, and they had, I don't know, 30, 40 questions per exam. They told us each question was referring to material covered in which week. So in a sense, we could say, well, we had the kind of a hard time reading each exam and trying to see, well, this person answered correctly question number 1, referring to week number 2. And maybe question number 2 was also referring to that week. So there was a hard coding exercise. But in the end, we had kind of grades per week, per course, per student. Again, multiplying, helping us multiply the sample a little.
How many weeks were the courses?
So 13 weeks was the term. Since we had to inform the students, wait for enrollment and so on, the first 2 weeks were not streamed, but we actually started it was 11 observations, if you want. 11 weeks. So,
Sorry, you said how many students?
1,600, a bit more than that, in the 2 waves, right? So, data gathering. Which is something that takes a lot of time, particularly for the postdocs. We had enrollment lists, of course, of all the courses. They had to do via some sort of Moodle. So there we got the enrollment lists in the first week, and we could do the random assignment, the assignment to treatment that we call. And then we got, for all the students enrolled, the administrative records of them. And here we had to do a lot of talking with the administration to be able to gather that data. Because there we want to have personal information, right? Like sex, age, country of origin, background characteristics about the parents. For example, if they were to high school or not, try to see whether, where they come from has also an influence on their grades, or actually to control for all these things. And crucially, we had the high school living grades that they had to report, la note de maturité. If they are in Switzerland or wherever they come from, we have their grades. So here, we had to kind of look in each country, what the scales were, what is the minimum passing grade, what is the maximum grade possible, and try to kind of normalize the grades of all students across to have a comparable measure. And this is what we use to measure ability. You may tell me, well, this is good or bad, but that's kind of as best as it could be for us. We didn't want to use anything related to university because, then we just run into mixing up stuff. We just wanted to have, before you join Geneva, how was your ability, let's say. For us, then, of course, we played a lot about, well, what is bad, low ability or high ability, what are good students or bad students. Here we play with thresholds all over to make sure that our results are robust. But what we do is pretty much take the 20% lowest of the distribution and consider them as poor students, let's say, 20% high ability, and people in between, like the regular student, let's say. Of course, we do have the log files of the streaming server, so we're able to see who connected when, for how long, to which course. So the students, just a little parenthesis, once they have access in 1 week, they can stream all the courses. So it's not that it's for one course, yes, for the other one, no. It's like either you have access that week, and you do whatever. You could potentially, stream one course and go to the other one. Then what we did also, actually, I was thinking about, if we had kind of chat AI back then, we could have very easily done this. We had an assistant taking pictures of the classroom from the back to try to see how many people were in the room, because we couldn't control access to the room. So we had this platform mTark that maybe you are familiar with. Is that freelance people that, they get paid to perform tasks. So we had them to try to kind of guess the head count in the classroom to have a measure of class attendance. I'm not going to show results about it, but it's trying to see whether it's consistent with the fact that if people are streaming, they are not going to class, or conversely. And the last piece of data that we gather is data on what we call weekly shocks, which are, what can impede a person to go to class in a particular week, or what can rise the cost of going to class, let's call it. So we gather weather conditions in Geneva, pressure, temperature, humidity, and all that, and then we try to classify bad weather, good weather, regular weather. We also had data on influenza outbreaks, whether there was epidemics or not. We had some data on traffic congestion, but then they were very much related to the weather in a sense, sometimes even maybe an accident every now and then, but that was not, we kind of didn't use it. And I'll show you why this data on shocks was useful. Well, I'm not going to show you the descriptive statistics of the sample, but what basically this is showing is that people are the same across the groups, showing that the randomization was good. We had the same number of female, same number of Swiss, same pretty much same grades, and so on and so forth, showing that the randomization was random. Let's say. Okay, so the first thing that we observed is that, first of all, most students that have access never stream. So this is kind of zero. So meaning it's like you stream 0 weeks out of the weeks that you have access. Now, if you just take out all these zeros and then focus on people that at least once got connected to the platform, you see that most of them, they just connect a couple of times. Meaning that, for example, if I had access during 10 weeks, I only connected 1 week, let's say, or 2. But very few of them connect all the time, meaning that if I have the 10 weeks I have access, the 10 weeks I stream. This is very interesting, actually. When you look at this, like, yeah. It's interesting because you may think that some people prefer to stream because they like this technology, and there is something fundamental about the technology that I like. And then some people don't, simply. And if that would be the case, then you would see, well, some people always use it, and some people never use it. Kind of like dispatch. But this shows like, oh, I eventually use it. Maybe it's when there is a shock, that there is something going on that makes me, this week I attend, and another one not. Well, that is consistent with the explanation that these shocks are random. It's very unlikely that I get hit by a shock every week, meaning like this week there's a snowstorm, next week there is a influenza outbreak, the other week, whatever, I didn't have access, but the other week again, there is a snowstorm. That's very unlikely, right? So, accumulating shocks would mean that the probability of observing that is smaller. Well, this is technical details, but it's just to provide an explanation of why people would use little this service. So then, if you forget about all that, the nice thing about an experiment in this context is the following. What we care about is the effect of the streaming service on student performance. But actually, we cannot simply correlate these two variables because there are endogeneity issues, right? It may be that something unobserved makes some students perform better in the exam and use the streaming service at the same time. So the experiment helps you work around that, meaning that, by randomly allocating people to access, you kind of control for all that unobserved heterogeneity somehow. So then all the econometrics behind to try to estimate that is right there, but we don't care about this. It's just able to show that the experiments, the fact that we assign people to a treatment is an instrument for the fact that they use the service, which in turn is what we care about. So just for the purists, what you just want to care about is, first of all, the stars, right? Those are the things that are statistically significant. So if you don't look by ability group, but you look at all students, you see there are no stars. In a sense, it's like there's no significant difference between people that stream and don't, basically, in terms of exam grades. They do the same in the exams. However, if you start dividing the sample by ability group, you find that we find that people with low ability, the probability of answer an exam question correctly goes down, whereas for those of high ability, it goes up, meaning that streaming makes you do better in the exam if you are high ability, and the contrary if you're of low ability. Why? Then you may think, well, I don't know, maybe you also already have some sort of hints from your background. Did you already come across this type of result? That good students benefit more from distance learning technologies than bad students?
Maybe the ones that are experienced already, they might do well anyway. From research I've done in project-based learning, actually. But the ones who needed to collaborate for the first time online, they would do worse and they wouldn't collaborate. It's not the same, but analogically.
Students who score higher on metacognitive regulation do better with groups, for example, and that correlates with ability measures. In which case, it's not ability which is contributing to them do better. It's ability is linked to their metacognitive regulation, and it's their metacognitive regulation which is enabling them to make use of it.
And it's easier to get distracted if you're at home. If you don't want to really focus, you don't have the will to do it, than if you're in class and you don't have anything else to do.
Yeah. There are many mechanisms actually that could explain.
If
Actually,
you
what
are a
we-
self-regulated learner, you will do well anyway. You online.
But what would you do better online than otherwise?
It doesn't matter if you're online or offline. That's what I mean. Then you are self-regulating, you will do well
In any case.
online. Yes.
Yeah. But then
They are better online.
They are better online.
They have more time and
The high.
yeah, that could be. But then one thing that is interesting is coming back again, is like, why don't they, because actually I didn't show something, but I should take up, right? I say, well, most students never take up, but actually this is the same for any ability. So it's not that high ability students stream more than the other ones. It's similar. They all stream 10% of the time. There is kind of like not, well, I mean, if they understood, it could be, yeah, but if they understood this mechanism, maybe they would prefer always to stream, right? Because they know that this is going to get them better grades. But of course, here we're looking only about grades, but students maximize many things, right? Maybe the comfort of staying home. I don't care of losing a couple of points in the exam if I just can, lay back in my couch, which is much more comfortable than these wooden chairs, for example. So this is something that also we kind of argue is like, okay, well, we are talking about bad effects, but maybe in terms of student welfare, this is good. Maybe students prefer actually to trade off a couple of points in the exam for the comfort of connecting at home. So here we're not saying, well, this is bad technology, bad for whom, for the prestigious of the school, maybe because they get lower grades, but for the welfare of the student population, maybe that's actually a good idea. So while we propose a mechanism based a little bit on literature from education literature that discusses this kind of technologies, learning technologies like in-person, online, and so on and so forth, to propose a little model that explains why good students do better than bad, and bad students do worse, by thinking about what would they have done otherwise if the streaming was not available.
Can I ask, sorry, I wasn't, because you went quite quickly through the empirical slide. I understand that there's an effect that the weaker students are doing less well, then the stronger students are doing better. How strong is the effect?
So this is about 2 percentage points, meaning that so we count kind of like the percentage of correct answers over the total number of questions. So on average, students answer correctly 50% of them. This allows them to increase 2 percentage points. So instead of 50%, well, instead of 50%, they answer 52% of the questions right. And this is also why is because there is little take-up, because they use it very little. Because all of a sudden, if everything was fully online, then this would be multiplied in a sense.
And what's that 2% as a proportion of the standard deviation? Is it a big difference? Is it?
Well, it is statistically significant. Then you may say, well, it doesn't, it's not going to be a game changer for the student in terms of.
You've got 1,600 people. Everything's statistically significant. I mean, how
Everything. I mean, if you've seen, it's only when we look at.
Every effect, even if it's tiny, will be statistically significant. I'm just wondering, like, do you have a Cohen's d or some measure of how big that 2% is?
Well, not quite like that. I mean, if you have the standard errors right there, so that's pretty much 1 percentage point, a little bit less for the intention to treat, because actually you cannot interpret this coefficient directly because this is the IV estimate. What you would have to do is multiply this by the take-up, which is 10%, and you arrive at that. So pretty much this is the number that gives you kind of a hint in terms of percentage point. As 2 percentage points lower grade for the bad ability, for the low ability, and 2.5 percentage points increased for the other ones. So the mechanism that we propose and that is consistent with the data of all the number of mechanisms that we kind of came up with, this was the only one that was consistent with the data. Then, of course, you may add COVID then, and then things would change, but what happens is, like, if there is a shock, big, well, this is a little snowstorm, but it was a big snowstorm, so there's a shock this week. And I'm a good student. I see this and I say, well, I just revise my notes. I can do that. I'm autonomous enough. I'm smart enough. I can learn on my own. I'll stay at home. Whereas for bad students, they know that if I miss this class, I won't get what's going on in my book. I don't understand, or I have a hard time to sit down and revise. So I just get my coat on, good shoes, and I'll go to class anyway. So if this is true, if the counterfactuals are different, this is consistent with the data. Why? Because the good student is changing going to class with streaming, and for him, going to class would have been better. So if we didn't have this technology, the guy would have gone to class and get a better grade. But given the fact that we're proposing him, he stays at home, so his grade is lower. For the good students, it's the opposite. They could have studied on their own, but looking at the lecture and hearing the professor, it's actually a little bit better for them than just simply studying on their own. So this is why things are working out better for them. So there is a whole model and based on literature and so on that kind of rationalizes a little bit this. That's on the paper. That's one mechanism. Of course, we didn't test the entire spectrum of. We did run a survey, exposed a long survey in the student community to try to understand what are the motivations for students to go to class or not. Typically, what we had thought before, it was like seeing a room overcrowded would make them, prefer to stay at home. But actually, it doesn't seem to be. This is not consistent with our data, and actually, the survey does not really show that students are looking at that much.
That's the question I had. How does it look like when you take attendance into account? So do you see a link with the overcrowding of the classroom? Or?
It's very, very little effect on attendance. It's pretty much, we see that there is 10% people streaming, pretty much take up. We would expect, well, there's 10% people less in the classroom. What we find is actually that there is a 6% less people in the classroom. There are many reasons why these two numbers are not the same. Of course, it's a very approximate measure of attendance, but the effect is very tiny. So actually, we do not see any effect. Well, if we jump into the conclusions, it's like we do not see any effect on classroom attendance in a sense. So the original idea of the university to decongestionner the rooms, this did not have an effect at all on that. So to wrap up about the study in itself, first of all, we find that students prefer classroom attendance. And second, that streaming is beneficial for good students in terms of exam grades and detrimental for the less good students. And these things have some implications for education policy, right? So the first one is, as I just mentioned, is like, well, if you wanted a solution for the problem of crowding, you have to look elsewhere. That was our first conclusion. The second one is like, okay, so the performance of the students may decrease, the bad students, but what about their welfare? This is what we were discussing before. It's like, can we simply say, well, no, this is bad for bad students or good? It's not clear.